Hello, geometry scholars! Today we're going to be continuing our work in section 2.7, Prove Angle Pair Relationships. That means we are going to be getting back into proofs today. Before we begin, please make sure you have your notes and something to write with. You will not need a calculator for today's lesson. If at any time the video goes too fast, you miss something, feel free to pause, rewind, and rewatch any sections you may have missed. Alright folks, let's go ahead and get started on prove angle relationships. And we're going to begin with example number 4, which is writing the proof for the right angles congruence theorem. Now recall, this is the theorem that simply states all right angles are congruent. So if you have right angles, then they are congruent. Now, when we prove a theorem, our basic rules for proving stay the same. We want to start with our given information and end with the proof statement. But something to be careful of, when we are looking at our reasons for each step in the proof, we have to remember we cannot use the theorem itself as a reason for justifying the theorem. Think about when you define a word. You can't use that word in the definition. It's not going to be helpful. If someone doesn't understand the word, using that word again to define it isn't going to allow them to understand what's going on. So same thing with proving a theorem. We can't use the theorem itself as a reason in the proof. We have to use other theorems, other postulates, other definitions to justify that this theorem is in fact true. So let's go ahead and get started. Let's see what we do know. Recall that if we have two angles that are right angles, then those two angles are congruent. That is the theorem we need to prove. So let's start with our given information, which isn't a whole lot in this particular problem. We only know that angles 1 and 2 are right angles. Well, let's consider that statement. 1 and 2 are right angles. What does that mean? Well, right angles are 90-degree angles. So let's say that next. Let's say the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees. And that's simply our definition of right angles. We know that if we have a right angle, then their measure is 90 degrees. Well, hopefully, this gives you an idea of what should come next. Look, angle 1 is 90 and angle 2 is 90. Both of these angles measure 90 degrees. So both of these angles have equal measures. So if two angles are equal to the same measurement, two things equal to the same thing, they have to equal each other. That's our transitive property. I would also accept substitution in this case. Well, from here, folks, we only have one more step. Our goal is to show that our angles are congruent. Right now, we have that their measures are equal. It only takes one additional step to get to congruence. And what allows us to do this is what we know about congruence. We define congruent angles as angles that had equal measures. So it's our definition of congruent angles, or definition of congruence, that allows us to make the change. This definition would also allow us to go the opposite direction. If we knew our angles were congruent, we could equally say that they are equal, using our definition of congruent angles. Alright guys, let's try the next one. Again, we're going to prove another theorem. This theorem is the vertical angles congruence theorem. Recall that this is the theorem that says that if we have vertical angles, then those vertical angles are congruent. Again, remember, this is not our definition of vertical angles. Our definition tells us where they're located. The theorem tells us their relationship. So let's give it a try. Let's start with our given information. And as we go through our proof, what is the one theorem we cannot use in this proof? Hopefully you said the vertical angles congruence theorem is the one theorem we cannot use as a reason in this proof. Alright, so we know we've got vertical angles. Let's see, what can we do with them? Well, we've got 5 and 7 in here, but we also have an angle 6. So let's consider how angle 6 might be helpful for us. Well, angles 5 and 6 are a linear pair. They have a total of 180. Angles 6 and 7, they're a linear pair. They have a total of 180. So let's use that fact and see where it takes us. And let's utilize our linear pair postulate to do so. All right, well, this sum equals 180 and this sum equals 180. That tells me my sums are equal. Again, I can apply my transitive property or the substitution property here. Since I'm working with equality, they are interchangeable. My goal is to get 5 and 7 to be congruent. Well, take a look. 5 and 6 equals 6 and 7. So we've got 6 on both sides. They're the same. We should be able to get those to cancel out using subtraction. If I subtract the measure of angle 6 from both sides of the equation, I can be left with angle 5 and 7 being equal. Now what allowed me to write step 4? I had angle 6 equal to angle 6. Those measures were the same. Did you remember the reflexive property? That's the one that says any angle is equal to itself. All right, folks, we have one more step here. Let's add an additional line to the bottom. We've got that the measures of our angles are equal, but we want the angles themselves to be congruent. Look back to the previous proof. What was the rule that allowed us to change the equality of angles into the congruence of angles? Take a look. Did you find it? Should be the definition of congruence, or the definition of congruent angles. All right, folks, we're halfway there. I want to take a moment and skip number 6 and jump down to number 7. This time we're not proving a theorem. We're simply proving a statement. They tell us that angles 1 and 4 are equal in measure. They're congruent. Our goal is to show that angles 2 and 3 are equal in measure, to show that they are congruent. All right, well, let's consider what we can do here. We know we have some equal angles, but let's look at our diagram to see what else we can do. Taking a look at the left-hand side, we have a linear pair, so their total should be 180. Taking a look at the right-hand side, we have a linear pair. Their total should be 180. So let's use that information. Again, we'll apply our linear pair postulate to do so. Both sums equal 180, so what does that tell us about our sums? They are equal to each other. Transitive property or substitution would be acceptable. Where can we go from here? Well, I know that 1 and 4 are equal. I know that the sum of 1 and 2 is equal to the sum of 1 and 3. We can do this in one more step. We can get this down to the measure of angle 2 equals the measure of angle 3. Do you see how we can do it? How can we fit these steps together? Specifically, step 1 and step 3 will get us step 4 as a result. Well, consider this. Remember that angles 1 and 4 are the same. So if we utilize our subtraction property of equality, we can subtract the same value from both sides of an equation. Now it's a different number, but remember they're equal, so we are subtracting the same value from both sides. So the 1's cancel and the 4's cancel, leaving us with 2 and 3 being equal. Alright folks, the last thing I'd like you to do is jump back to problem number 6. This one asks you to prove the congruent supplements theorem. This says if two angles are supplementary to the same angle, then those two angles are congruent to each other. Take some time, try this proof. You know that these two angles are supplements and these two angles are supplements. Your goal is to show that these two angles are congruent. Look at your previous proofs that we went through in today's video. Use those to help you get some ideas and to model what you need to do for your steps. After you're finished, make sure to check the answer key to see how you did. Alright folks, you are done with your notes for today after you've finished example number 6.